Are you excited to finally learn about the mole? Well, this is not the mole that we're going to be learning about. We're not talking about a furry rodent, nor are we talking about a mole on somebody's face. We are talking about a word that actually means a number. What do I mean by that? Well, there are several words that mean numbers. One you might have been familiar with is 1 dozen. 1 dozen something equals how many things? And most of you know, if you're familiar with donuts, that it's 12. This is a word that means a certain number of things. There are several words like that mean a number of things. I could say 1 gross. Now, some of you might not be familiar with some of these words as you are with dozen. 1 gross equals 144 things. A gross is really a dozen. So if I have a gross of donuts, I have 144 donuts. I could say 1 ream of paper. That's a word that means a certain number of pieces of paper. It means 500. So, these are words that mean numbers. Certain words have meaning, and they mean numbers. So that is simply what a mole is. A mole, 1 mole, equals, the problem is it's a very big number. The number is 6.02 times 10 to the 23rd power. 1 mole is 6.02 times 10 to the 23rd power of things. So if I had a mole of donuts, I would have a whole lot of donuts. This is a very, very large number. This number is called Avogadros number. It was named after Amadeo Avogadro. Avogadro didn't actually come up with this number, but it was named after him. So a mole is Avogadro's number worth of things. 1 mole is 6.02 times 10 to the 23rd things. And what we're going to talk about later, why this number is very important in chemistry. This number is actually so important that on October 23rd, which of course would be 1023, 10 to the 23rd power, from 6:02 in the morning to 6:02 in the evening is National Mole Day. National Mole Day. It's when we have our National Science Convention meetings in the United States. It's the National Mole Day, October 23rd, 6:02 to 6:02. So it's a very important number that we're going to be using in chemistry. As we talk about this, one thing I want to look at is how big is this number actually. So it's hard for us sometimes to understand how big 1 mole is. 6.02 times 10 to the 23rd is a very large number. And to put it into perspective, let's assume that I could live to be 1,000 years old. 1,000 years old. And let's say that I could, my entire life, I wouldn't have to sleep or anything. I could make 1 dot per second on this iPad. 1 dot per second. How many dots would I be able to make in 1,000 years? Would I be able to draw a mole of dots or not? So one thing we can do is dimensional analysis here and convert this just to see how big a mole actually is. I could say, well, in 1 year there is 365 days. And in 1 day there are 24 hours. And in 1 hour, there is 3,600 seconds. And if I multiply all that out, I would get 3.15 times 10 to the 10th dots. So 1,000 years of making it 1 dot per second, I'm not even close to a mole of dots. Some people might say, well, yeah, but you get faster. You could maybe do 2 dots per second. You go a lot faster, do 2 dots per second. Well, if I go 2 dots per second, what does that do to this number? Well, all it does is it makes it 6.30 times 10 to the 10. It doesn't even change the exponent. It just doubles 6.30. So that wouldn't do any good. What if instead of living for 1,000 years, I could live for 1,000,000 years? Well, that'd be 3 more zeros. That would then change this number to 6.30 times 10 to the, and instead of 10, I'd have 13. So you'll see, I'm still not anywhere close to a mole of dots. Even if I could make 2 dots per second for 1,000,000 years, I'm not going to come anywhere close to a mole. This is a huge, huge number, a ginormous number. And the reason it's so big is because we're using this number to really explain how many particles, like atoms and molecules and things, we have in a given amount of substance. And atoms and molecules and things are very, very small. So we need a word that means a large amount of things so that we can start describing things like water molecules and carbon atoms in terms of what we can see every single day. So if I said that I had 1 mole of, we'll say, copper atoms, 1 mole of copper, then I would have how much copper? Well, what I need to look at here is what is the representative particle. It's called the representative particle. What is the representative particle of an element? Which means, what is the smallest part of an element that you can have and still have an element? So if I said 1 mole of copper, I would have 6.02, and we can write this in the ELAB, E23 instead of times 10. 6.02 E23 atoms of copper. Atoms would be the representative particle for an element. What if I had 1 mole of water, H2O? 1 mole of water, what would that mean I have? That would mean I have 6.02 E23 molecules of water. Molecules would be the representative particle for covalent compounds. So atoms is the representative particle for elements. Molecule would be the representative particle for covalent compounds. What if I had 1 mole of table salt, NaCl? What would that mean I have? It would mean I have 6.02 E23 formula units of NaCl, sodium chloride. Formula units is the representative particle for ionic compounds. So here I have elements, covalent compounds, and ionic compounds, and over here is the representative particle for that. So I want us to understand when I say I have 1 mole of iron, 1 mole of iron, you understand what that means. That means 6.02 times 10 to the 23rd atoms of iron. Here's a tricky one. What if I said I had 1 mole of oxygen gas? Oxygen gas is O2. what would 1 mole of oxygen gas be? Well, it would be 6.02 times 10 to the 23rd molecules of oxygen gas. Even though this is an element, most of the representative particles of elements are atoms. But this one, there's 7 of them that are molecules because they're diatomic. So, we're going to talk more about this number, obviously, when we're talking more about the mole and Avogadro's number. But right now, I just wanted you to understand 1 mole is a word that means a certain number. And when we're talking about 1 mole of various things in chemistry, we're talking about this many atoms, or this many molecules, or this many formula units. So I hope you have that number memorized, because we're going to use it a lot here in the future.